Bismillahirrahmanirrahim. Welcome to the second part of the 16th lecture of statistics and probability theory. We will continue with the topic Poisson distribution. As we were studying the binomial approximation to the Poisson distribution, that is whenever number of trials n becomes very large and p, that is probability of success, becomes very small, binomial distribution can approximate to Poisson distribution with parameter mu, where mu is equal to n, which is number of trials, into p, which is probability of success. Example number 1. In a certain industrial facility, accidents occur infrequently. It is known that the probability of an accident on any given day is 0.005 and accidents are independent of each other. What is the probability that in any given period of 400 days there will be an accident on one day? So as you concentrate on the statement of the example, they are saying that accidents occur infrequently. As we are studying the Poisson distribution, and Poisson is the distribution of rare events, so this is quite justifying. This statement is quite justifying the Poisson distribution's properties. The probability of success is 0.005, as we are interested in the probability of an accident on one day, and an accident on any given day's probability is 0.005. So this is the probability of success, and as they are studying the period of time, which is 400 days, so this is the number of trials. So if you recall the properties of the binomial distribution, the very first property was that the experiment is classified into two outcomes, which is success and failure. Here we are interested in the accident in a given day, so this is the success for us. Otherwise, second property is that the experiment is repeated a fixed number of time. So here they are considering 400 days period of time, and the third property was that each successive trial is independent. So here it is written that accidents are independent of each other, which is justifying the third property. And the last property is that the probability of success is constant from trial to trial. So it is written in the statement that probability of an accident on any given day is 0.005. So this statement is satisfying the all four properties of the binomial distribution, but you can see that here n, which is number of trial, is very large, which is 400, and p is very much small, which is 0.005, which is quite close to 0. So we can approximate this binomial distribution to Poisson distribution with parameter mu. So here in part A, random variable x represents the number of days with an accident. And as you know that n is equal to 400, P is equal to 0.005. So mu will be equal to N into P, which is 400 into 0.005, which is equal to 2. So by using Poisson approximation, the probability distribution function is e raised to power minus mu raised to power x over x factorial, where x is equal to 0, 1, 2 up to so on. As we are asked that we have to find out the probability that in any given period of 400 days there will be an accident on one day. So x is representing the number of days with an accident, and we know that by substituting x is equal to 1, we will get the probability that there will be accident on one day. So as you know that mu is equal to 2 and x is 1, so by substituting this value in the probability distribution, we will get the probability 0.271, which is the probability that there will be an accident on one day. Part number B. What is the probability that there are at most 3 days with an accident? We have already learned that at most means that this is the maximum limit, and at least means minimum requirements. So here they have written that at most 3 days with an accident. So you have to find probability x, as x is the number of days with an accident, is less than equal to 3, because the word at most is used here. So we can't go beyond 3. So by substituting the values, mu is equal to 2, as we know, n is equal to 400 and p is equal to 0.005. By using Poisson approximation, probability x is less than equal to 3 will be equal to probability x is equal to 3 plus probability x is equal to 2, probability x is equal to 1 plus probability x is equal to 0. By substituting the probability distribution function, which is e raised to power minus mu and mu raised to power x over x factorial, and we know that value of mu is 2. So by simplifying this, we will get e raised to power minus 2 raised to power 0 over 0 factorial plus e raised to power minus 2 raised to power 1 over 1 factorial plus e raised to power minus 2 raised to power 2 over 2 factorial plus e raised to power minus 2 and 2 raised to power 3 over 3 factorial. So by simplifying this, you will get the probability 0.857, which is the probability that there are at most 3 days with an accident. Example number 2. In a manufacturing process where glass products are made, defects or bubbles occur, occasionally rendering the piece undesirable for marketing. It is known that, on average, 1 in every 1,000 of these items produced has one or more bubbles. What is the probability that a random sample of 8,000 will yield fewer than 7 items possessing bubbles? So what's happening here? There is a manufacturing process of a glass products, and rarely or occasionally defects or bubbles occur in the piece, which is undesirable for marketing, and the chances of the item to be defected or with bubbles is 1 in every 1,000, which is very small. So they are asking that they are taking the random sample of 8,000, and we have to find out the probability that fewer than 7 items possess bubbles. So as you can see from the explained scenario, that there are two possible outcomes, that either the glass product will be non-defective, or either it would have any defect or bubbles. As we are interested in the items possessing the bubbles, so this is the success for us, otherwise the failure, and the chances of the product to be defective is on average 1 in every 1,000, which is P is equal to 1 over 1,000, and they are taking a random sample of 8,000, so N will be equal to 8,000. So the first property, that there would be two categories, success and failure for binomial distribution, is satisfying here. The second property is that the number of trials are fixed. They are taking the random sample of 8,000. So this property is also fulfilling here. The third property is that the successive trials are independent. So each item or glass product is independent from the other glass product. So this property is also fulfilling here. And the very last property is that probability of success remains constant in each trial. So as you know that this P is 1 over 1,000, which means that on average 1 in every 1,000 of these items would be defective. So this will remain constant in each trial. So this scenario is following binomial distribution, but the probability of success P is very small and the number of trials are very large. So we can approximate this binomial distribution to the Poisson distribution with parameter mu, which is n into p, which is 8,000 divided by 1,000. So as they are asking that find the probability that fewer than 7 items possess the bubbles. So it means probability x will be less than 7, as x represents the number of items possessing the bubbles. 7 will be not included in the scenario because they are asking fewer than 7 items. So it will start from probability x is equal to 6 plus probability x is equal to 5 up to so on. It will end at probability x is equal to 0, as we know that probability function is e raised to power minus mu raised to power x, over x factorial where x is equal to 0, 1 up to so on. By substituting these values here, we will get e raised to power minus 8 into 8 raised to power 6 over 6 factorial plus e raised to power minus 8, 8 raised to power 5 over 5 factorial up to so on. It will end at e raised to power minus 8 and 8 raised to power 0 over 0 factorial. By simplifying this, we will get the probability 0.3134, which is the probability that fewer than 7 items possess the bubbles. Example number 3, the probability that a student at a local high school fails the screening test for scoliosis, which is the curvature of the spine, is known to be 0.004. Of the next 1,875 students at the school who are screened for scoliosis, find the probability that fewer than 5 fail the test. So if you concentrate on this statement, they are saying that students are going for the screening test for the curvature of the spine, and the probability or the chances of the screening test which they fails is 0.004, and they are taking the sample of 1,875 students at the school, and they are asking the probability that fewer than 5 will fail the test. So by considering the properties of the binomial distribution, the very first property is, as you know, that there are two categories, success and failure. And here our success is the student who fails the test. Otherwise, it is failure. So we have two categories. Second property is that number of trials are fixed. So they are taking the next 1,875 students. And the third property is that successive trials are independent. As you know that each student is independent from the other student, so this property is also fulfilling here. And the very last property is that probability of success is constant, which is 0.004 for the student. So P is equal to 0.004, which is quite small, and N is equal to 1,875, which is very large. So we can approximate this binomial distribution to the Poisson distribution. As you know that random variable x will represent the number of students fail the test, Therefore, n is equal to 1875. P will be equal to 0.004. So mu will be equal to n into P, which is 7.5. And as we are asked that we have to find out the probability that fewer than 5 will fail the test. So this will be probability x less than 5. 5 is not included as they are asking fewer than 5. So it will be equal to probability x is equal to 4 plus probability x is equal to 3 up to so on probability x is equal to 0. So as you know that probability distribution function is e raised to power minus mu into mu raised to power x over x factorial, and value of mu is 7.5 and summation x is equal to 0 to 4 as probability x is less than 5. So by substituting the values of x, which is 0, 1, 2, 3, 4, and by simplifying this, we will get the probability 0.1321, which is the probability that fewer than 5 will fail the test. Part number B. Find the probability that 8, 9 or 10 will fail the test. So, as you know that x is a random variable and it is the medium of our interest and it represents the number of students fail the test. Therefore, as you know that mu is equal to 7.5 and they are asking that 8, 9 or 10 will fail the test. So this basically probability 8 less than equal to x less than equal to 10, which will be equal to probability x is equal to 8 plus probability x is equal to 9 plus probability x is equal to 10. So this could be written in this way: summation x is equal to 8 to 10, and as the probability distribution function is e raised to power minus mu raised to power x over x factorial, and the value of mu is 7.5, which is the mean of the binomial distribution and parameter of the Poisson distribution, as we are approximating Poisson distribution when n is equal to n is very large and p is very small, and here n is 1875, which is quite large, and p is 0.004, which is very small. So by substituting the values and simplifying it, we will get the probability 0.3376